Hi, everybody. This is lesson 4.4, um, and we're going to start off by looking at the cool down from the last lesson. And so it starts with an art museum opens up at 9 a.m. and closes at 5 p.m. The function v gives us the number of visitors in a museum h after it opens. Explain what this statement tells us about the situation. Okay, so all right, remember these are input outputs. So if the input is 1.25, all right, that's hey an hour and a quarter. Okay, so what's a quarter of an hour? 15 minutes. So an hour and 15 minutes after the store is opened, there is 28 visitors in the museum. And so if it's an hour and 15 minutes later, at 10:15 a.m., there are 28 visitors in the museum, if I can spell museum correctly. Go. Use function notation to represent that at 1 p.m. there are 257 visitors in the museum. So, guys, again, if you are struggling with figuring out where things should go ahead and write the way it looks. Okay, and so we know that the function of v, and then this would be after how many hours, and so it's at 1 o'clock. That is 10, 11, 12, 1, so 4 hours later. Okay, there's 257 visitors. Now, use the function notation to represent that at the end of closing, there are no visitors there. So from 9 to 5, okay, 10, 11, 12, then you have 5 more hours. So after an 8-hour day, so V of 8, okay, you're going to have 0 visitors. All right, so that's function notation again. So to review that, so then today in 4.4, all right, is what we're going to attack. So what do you notice? What do you wonder? All right, here's 2 functions. What are a couple things that you notice about these? Is that there is no input or output on any of these. There's not saying that. Okay, let's see. One is f of x. All right, the other is g of x. Okay, we could even say that one of the functions is linear. Okay, we see that f of x is linear the way it is, but then this is x cubed. That's actually a polynomial. The other is a polynomial function. Okay, what questions do you have about the graph? Maybe what do they represent? I mean, that's about it that I have. Okay, but you guys might have some, looking at them for the first time. So remember, guys, these I like to call my factories because you're putting in the ingredients and it's spitting the output out, and it's always the same every time. All right, so one input, one output. Okay, multiple things can equal the same thing, but one thing can't equal 2 things. Okay, again, if I plug a 2 in, I can't get a 4 one time and then a 6 the next time. It doesn't work that way. But if I plug a 4 in, I can get a 2, and if I plug a 6 in, I can get a 2. That's okay. But it's just one input has, the input has one output. So this says that it takes any input and cubes it to generate the output. So g of 0. All right, what's 0 cubed? 0. That's pretty easy, right? What's 1 cubed? 1 times 1 is 1, times 1 is 1. Correct? 3. What's 3 cubed? 3 times 3 is 9, times 3 is 27. And then, guys, now what if it's just x? So x times x, it's not 2x, it is x squared. Then taking another x, so x squared times x, we're going to be x cubed. Okay? All right, now we're going to match each equation with a verbal description that represents the same function. All right, so make sure that we're reading these aloud. And so this right here, guys, remember we work inside out. So for like f of x here, I'm going to multiply by 3, then subtract 7. Let's see. It says multiply the input by 3, then subtract 7 for the result. Okay. See, on this one, guys, to get the output, you're going to divide by 3, then subtract 7. There we go. That's D. Let's look at this. Okay, remember we solve parentheses first, PEMDAS. So I'm going to subtract 7, then multiply by 3. All right, which one of these? Okay, they both say subtract 7, but then this says then multiply the result by 3. And then here you have, we're going to divide the input by 7, and then, subtract the input by 7, then divide by 3. Okay, all our pairs are correct. All right, for which one of these functions, when the input is 6, the output is -3. Okay, let's look here. Let's see, if I plug a 6 in there, 3 times 6 is 18. 18 minus 7, okay, is going to be 11. Let's see, this is my input here, right? So 6 minus 7, that's a -1, times 3 is, hey, that's going to be -3. Okay, so we're going to use, let's see, g of x there. Okay. Ooh. All right. Let's look at this. Okay, we're given a couple functions here. Which of these functions is the greatest when the output is 0, or when the input is 0? So remember, when we multiply by 0, we get 0. So this is going to equal just -7. 0 minus 7, we say that this is 0, is going to give me a -7, which times 3 is going to be a -21. Okay, 0 times 3 is 0, so this is going to give me a -7. And then 0 minus 7 is -7, and then this is going to give me a -7/3. Okay, so we can see here, guys, that when we do these, g of x is the greatest. All right, what if the input is 10? All right, okay, so 3 times 10 is 30. 30 minus 7 is 23. Okay, 10 minus 7 is 3. 3 times 3 is 9. So we're no longer, g of x is no longer the greatest. 10 divided by 3 minus 7 is not going to be greater than 23. And we know that 10 minus 7 divided by 3 is not going to beat 23. So we do have f of x as our highest one. Okay, let's see, we just did that. All right, sorry. The expression of functions f and g both involve multiplying by 3 and subtracting 7. Okay, how are they different? This one, guys, it's very straightforward. Okay, you're going to make sure that it's order of operations. So f of x, you're going to multiply first, then subtract, right? Because I'm going to multiply this, then subtract it. But on g of x, we do our parentheses first. So I'm actually going to subtract first, then multiply. Okay? There we go. The expressions for h and k both involve subtracting and dividing by 3. How would you decide which one corresponds to description A and which one corresponds to description D? Okay, well, guys, we look here, and remember, we're going to use order of operations first. And so when it looks like this, okay, the best thing that we can say is that is like saying, if we drew this, or if we wrote this horizontally, x minus 7, divided by 3, well, you would reduce the parentheses first, right? And so that's a good way of thumb to know, hey, when do I do first, okay? And so because of that, here I'm going to divide by 3 first, then subtract 7. And on this one, I'm going to subtract 7, then divide by 3, okay? So we did really describe it there, so that just means that h of x, corresponds with description. Let's see which one. D. We're going to divide the input by 3 first. Okay, now let's talk about rules for area and perimeter. Remember area, guys, that we are going to multiply length times width, but since it's a square, we know that all the sides are going to be the same, right? And so that means that we're going to take this side times this side. So we see here the side length. If the side length is 1, the area would be 1 times 1, which is just 1. What about 2? 2 times 2 is 4. 4 times 4 is 16. 6 times 6 is 36. What's s times s? Not 2s. S squared. Okay. All right. A square that has a length of 9 centimeters has an area of 81 centimeters squared. The relationship is a function. What does A2 represent in this situation? And so A2 represents the area of the square when the side length, gosh darn it, sorry, length is 2 centimeters. That's what that is saying. So the input is 2. Okay, what do we do? And what is that value? Well, we come up here. 2 is 4. Correct? Flame emoji. All right. Now, we have this on the coordinate plane. Show the graph of the function. So we see at 1, we are at 1. So it'd be like right here. At 2, we are at 4. Okay, I'm only going up almost halfway. Then we jump up, where would we be at 3? We'd be at 9, right? Okay, and then at 4, we jump up to 16. 6, we jump clear up to 36. We know that 5, we're at 25, because 5 times 5. And 7, we're at 49. Okay, so that would be our graph. And so what you're going to see is you start at 0 and it goes off slow. And then with this being squaring each one, it is going to be exponential in that growth. Okay. The next slide. So I'm sorry, we did that. Okay, so a roll of paper that is 3 feet wide can be cut to any length. If the length is 2.5, what is the perimeter? So guys, remember in the perimeter, we add up all slides. So like this is 2.5, right? So that means that this is 2.5. And then if this side is 3, we know that this is 3. So if we are adding up all the sides, this and this give me a 5. Oh, sorry about that. We know that that's going to give me a 5 plus 3 times 3, which is 6, which is going to give you 11 feet, and that is correct. Very good. Okay, so now guys, what about when each one is 1? So what you're doing is you're going to double it, because it's the same on both sides. So 1 plus 1, it's going to give me a 2. Then I have the 3 on both sides. So if we know that it's 3 on one side and it's 3 on the other, my lengths are going to total what? I'm going to add 6 to that. So 1 times 1 1 plus 1 is 2. 2 plus 6 is 8. 2 plus 2 is 4. 4 plus 6 is 10. Ooh, 6.3 plus 6.3 is 12.6. 12.6 plus 6 is 18.6. 11 times 11, okay, is what? 11 times 11 is 22. 22 plus 6 is 28. And then, oh golly. Okay, so this is going to be 2L plus 6 because we know that the length, we're going to take 2 times the length and then add 6, so 2L plus 6. All right, a roll of paper that is 3 feet wide can be cut to any length. What does P of 11 represent in this situation? And we're going to say that that is the perimeter, right, of a roll, a perimeter of a piece of paper that has a length of 11 inches, because that's the input they're giving us. And what is its value? We come down here, and that's 28. All right, let's graph this. They do let us mark on this. So we say at 1, we're at 8 here. Okay. 2, we're at 10. I can get on the mark there. Then at 6.3, we're kind of around here. We're at 18.6, so like somewhere around there. And then 11, we're off of that, okay? And so, you could go through here, hey, what if it was at 3? 3 plus 3 plus 3 plus 3. That's going to give you 18, right? No, go back out. Let's look at that. 3 plus 3 is 6. 3 plus 3 is 6. It'd be 12. What am I thinking? Must be the snow day. And then if it's 4, 2 times 4 is 8. 8 plus 6 is 14. Okay, and so this would be kind of how we are connecting those. Okay? All right. How would you describe to a classmate who is absent today what each equation means? Okay. All right. You would basically say the left side of the equation will give us the input, right? And the right side of the equation will tell us what to do to the input to get the output, right? So if it says like f of x, or f of 2 equals x plus 3, that's basically telling you that, hey, take that 2 and add 3 to it to get 5. All right? How do the rules help us find the value of f of 10 or g of 10? Okay, those rules would help us by showing us, hey, what are you doing to 10? Since I don't have f of 10 and g of 10, I can't do it. But it would tell you what to do to that input to get the output. And then, is it possible to graph a function described this way? And if you have the rules, yes, absolutely. Okay, I don't if I don't know the stipulations. If it just tells you randomly, hey, f of 10 is 28. That gives me 1 point. I can't go off that. If I get 2, then yeah, I can find a rule. But no, we can't do anything with that unless we know the rule. And then complete the table with the perimeter of a square. And so, guys, with a square, we know that that they all add up the same, right? So if 0.5 is the side of one, then it has to be the side of the other. So if I do my perimeter, a half plus a half gives me a whole, plus another half will give me 2 wholes. Okay. What about 7? Okay, so we're going to take 7 times 4, which is going to give me 28. And then if it, guys, is a 20, okay, 20 times 4, or 20 plus 20 plus 20 plus 20. Okay, so 20 times 4 is going to give me 80. Now use a rule for function p that gives the perimeter of square in inches when the side length is x inches, okay? Guys, you're taking it times 4, so it's just 4x. All right, you'd rather do that than write x plus x plus x plus x. It doesn't work that way. Write 4x. And then what is the value when p is 9.1? You need to take 4 times 9.1, okay, which, we know that 4 times 3, or I'm sorry, what am I doing? 4 times 9 is 36, so it has to be 36 plus 4. All right, guys, that is lesson 4.4 in a nutshell. And hey, that brings us to the conclusion of class through winter break. So tomorrow we'll do an activity, but this is the actual last lesson in the year 2020. We made it. All right, so let us know if you have any problems with the classwork, and we'd be happy to help you. Other than that, ain't nothing to it but to do it. Have a great evening.